The vectors A is equal to 3i plus 4j and B is minus 4i plus 2j are such that the dot product of A and B is 2p. Find the value of P. So to find the value of P, you can take advantage of this fact. So we have 3i plus 4j being multiplied by, remember this is your A, being multiplied by this. So we have the dot product of minus 4i plus 2j is 2p. So now let's solve for p. Remember, when you are multiplying vectors, just multiply the i's by the i's, the j's by the j's. So you can say this multiplied by this is minus 12, then plus 4 multiplied by 2, we have an 8, then this is 2p. So when you add these two, you have minus 4, which is equal to 2p. Okay, so it's too easy. Then you can divide both sides by 2, so that your p is this into this is minus 2, and you're done. And then the unit vector, okay, find the unit vector in the direction of B. So now we want to find the unit vector in the direction of B. So B is minus 4i plus 2j. So to find the unit vector in the given direction, all you need is that direction divided by its magnitude. So in other words, the unit vector, we normally say b cap of in the direction of b is given by, you get the vector b, which is minus 4i plus 2j, you divide it by its magnitude, which is minus 4i plus 2j. So the magnitude of this is, you can just use the Pythagoras theorem, square this, so you can say minus 4 squared plus, you square this, 2 squared, like this, so that you have minus 4i plus 2j, everything over minus 4 squared is 16, 2 squared is 4, and then you have minus 4i plus 2j, everything over this plus this is 20. So now you can find the square root of 20. And actually you can even leave it like this, but when you're dealing with surds, it's better to rationalize it. You want to avoid having denominators with roots, so you can, maybe let's just use the usual methods of punching this on our calculators. So we have 4.4721. So if you were to convert this to surd form, this would be the square root of 20 is, you can write 20 as 4 by 5, then the square root of 4 is 2, the square root of 5 is an irrational number, so you can use this as your denominator, but do not leave this here. You have to multiply by this thing here, like 2 root 5 over 2 root 5, but I don't want to go there. And then at this point you can either leave it like this, or you can separate the two, so that you have minus 4i over 4.4721, then plus 2 over 4.4721j, which rounds off to minus 4 over 4.47i, then plus 2 over 4.47g, and you're done. And then on part B, finds the angle between the vectors. So we have vectors, column vectors 3, 4, and 5 minus 12. So to find the angle between these two guys, you can just say the dot product. Let's just say this is A, this is B. So the dot product of this is equal to the magnitude of this multiplied by the magnitude of this multiplied by cos theta, where theta is the angle between the two vectors. So your A is this dot, your B is that, and then to find the magnitude of A, you can just square the x. Remember, this is the x, this is the y. If you are using ij components, this would be the the I, this would be the j. So we have 3 squared plus 4 squared, then multiplied by the square root of you get the components of this. So you have 5 squared plus minus 12 squared, and then cos theta. So now to multiply these two, I know they look like matrices, but they are not. These are vectors. So these are like i's, these are like j's. So you can just say this multiplied by this, which is 15, and then plus this multiplied by this, which is 48. In case this is confusing you, just express it in ij component form like this. So we have 5 minus 12, 5i actually, like this. Then you can see this multiplied by this is 15. And then plus this multiplied by this will be negative 48. And then now you can add so that you have this 8 minus that, we have a 3, so that's like a minus 33. So you can either use column vectors, or you can use this, but if you've been given this, it's better to stick to the same thing you've been given. So this one squared is 9, this one squared is 16, together we have a 25, so plus 16, then multiplied by this one squared is 25, this one squared is 144, and then cos theta. So now when you add these two, you have negative 33, you have negative 33, and then this plus this will be 25, and then multiplied by this plus this is 169, and then cos theta. Okay, we have nice numbers here. And then the square root of 25 is 5, the square root of this is 13, multiplied by cos theta, this times this will be 65 cos theta, divide both sides by 65. So we can continue this from here. We have cos theta is minus 33 over 65, and then you can use your calculator. So from here we can just find the cos inverse. I don't think you need the alpha here, you just need that exact angle. So we have minus 33 divided by 65, which is 120.5104. So let me just check, is the answer supposed to be in degree? Okay, they didn't really state, they just said find the angle between vectors this and this. So the angle will be 120.5. Remember, For angles in degrees, you have to leave your answer in, you have to round your answer correct to 1 decimal place, like that. You're done.